Hello, maurieos. Land Surveying 1, Session 9, Linear Measurement. Well, welcome to this, the 9th session of Land Surveying 1. And in this session, we're going to be looking at linear measurement and the various aspects of linear measurement. So, let's go to the large screen and see what we've got. Okay, so what's the plan? Well, this is the plan. It's pretty much the standard plan that we've used for most of the other sessions, where I'll hand out the documents associated with the particular session, and then we'll go through the various aspects of that, perhaps a little simple survey concept, and then we'll go on and have a look at what Moodle has to offer. Associated with this session will be a 4-hour practical, where essentially we will be doing more work associated with the traversing assignment and moving on from the excellent start we made to that in the last session. So let's have a look. Key learning outcomes. On the successful completion of this session, you should have examined the concepts of linear measurement. So we will be having a look at how linear measurement goes together. There's quite a bit of workflow associated with it, and order and various concepts associated with linear measurement that are very helpful to know, and a huge part of surveying. Just to reiterate, linear measurement is where we're measuring the length of the survey lines. You will have reviewed the order of linear measurements. So we do linear measurements and reduce them in a particular order, and if we get out of that order, things can go horribly wrong. You'll learn a little bit about prism constants, and in particular how important they are, that you apply the right particular constant at the time to the particular prism. So that does vary prism to prism, so you need to always be on the lookout to make sure that you've got the correct prism constant keyed in for the prism that you're using. We will be looking at curvature and refraction and what effects this can have on linear measurements, and in particular linear measurements over long distances. We will be reducing linear measurements, and we will be look at, obviously we treat different short length ones are slightly different than longer length ones. Obviously there's more things come into play with the longer length. So over a short length up to maybe a couple of 100 meters is not too many issues that we need to be overly worried about. We can cater for them quite adequately. But when we're starting to look at longer lines, 2 and 3 kilometers long, that we're measuring with EDM, electromagnetic distance measuring, we have to be a little bit more careful. Okay, we will then be starting to look at closing traverse bearings. As things progress with the traverse assignment, bearings will need to be closed, and have a good understanding of closing traverse bearings. It's a huge part of traversing. And we will be also, not only do we have to close the bearings, but we have to close the distance for close the traverse for position and distance. So if we start at a point and do a whole lot of measurements and come back to that point, we need to show that that is in fact the case, and the amount that we miss by is called the miss close. And we also have to close our traverse heights as well. So quite a lot of things to go through there, and the successful learning outcomes, we will encounter all of those in this unit. Okay, so moving right along, this week's simple survey concept, and I have actually done this as a separate video, but I will do it again, incorporated inside this introduction, because it is an important aspect of what we do, and something that we need to know very well. That bearings are measured clockwise from north. So north obviously usually is up the page, or that's how we try to do it, like that most of the time, and it is either 0 or 360 degrees. The bearings are then measured clockwise around there from 0, 90 degrees east, 180 degrees south, 270 degrees west, and then back around to north again, obviously at 360 degrees, or start again at 0. So no bearings are expressed with a number greater than 360. So if, say for instance, you do have, say for instance, you had a bearing at 300 and you added an angle of 80, that would give you 380, but we wouldn't show that as 380 degrees. If it's more than 360, we just take the 360 off, so that would be 20 degrees. Okay, moving right along. So the bearings indicate a direction. So as you know, we can walk in a particular direction, facing in that direction, and then we can turn around through 180 degrees and we're looking in totally the opposite direction, but the actual line is the same. It's just in the one case we're walking towards, say, a point, and then we turn 180, we're walking away from the point. So the actual direction is physically the same, but depending which way we're looking, they will be 180 degrees different. So for instance, if we take the bearing in this slide here, the bearing from A to B, that has a bearing of 35 degrees 15 minutes 20, we can see that the bearing clockwise from north is the small angle shown or depicted here. Okay, 35 degrees, and that's awesome. Okay, but if we want to look at the bearing from B to A, and we're at B to A, and we're going north would be up the page, the angle would be all the way around there, 180 plus the 35. So it would be 215 degrees 1520. And that's, I guess you could call that the reverse bearing if you wanted to, if you wanted a name for it. So to reverse a bearing, if the bearing is anywhere between 0 and 180, we add 180 degrees onto it. So 35 degrees 1520 plus 180, 215, 1520. And if the bearing is more than 180, we take 180 away. So if, say, for instance, 215, 1520, we wanted to reverse that, take 180 off, 35, 1520. So let's have another example here of C to D. 327, 2630 is the bearing, and that angle measured from north is this angle measured all the way around here. Okay, so that's C to D. That's fine. We can see that fits in with what we had previously. But if we wanted to look at the bearing D to C, well, that's not obviously going to be 320, 2630. So we take 180 off, and 327, 2630 minus 180, 180 is 147, 2630. So reversing a bearing. To reverse a bearing, if the bearing is less than 180 degrees, add 180. If the bearing is more than 180 degrees, take away 180. It's all fairly simple. And, if you make a mistake, it probably doesn't matter. Because if the bearing, say, was more than 180 and you added 180, you'd go past 360, and so you just subtract the 360 off. If the bearing was less than 180 and you subtracted 180, you would get a negative bearing there, and a negative, you just add 360 and it would give you the right one. So you can't really go wrong with this. It's all, like I said, it's a simple survey concept. Just remember, bearings are measured clockwise from north. Now, when we measure in our traverse, we measure on both left face and right face. Why do we do this, you might ask? Well, it eliminates a number of inaccuracies present in the total station, in the sense that if you have a slight error, you measure on left face, the error might be slightly to the left of the true position. If you flick it over onto right face, it'll be in the opposite direction or slightly right. So if you mean the two out, take the mean of the left face and the right face, that'll get you, it'll eliminate the error and get you bang on. So there's quite a lot of notes on this that I've provided in the course Moodle site, but from the theodolite and its applications, theodolite adjustment extract, and some student reference notes. So quite a lot of reading on that, well worth looking at, just to get yourself in the zone and get a good understanding of this. Now, I've got here a little diagram with the what we call the orientation correction, or what have you. So let's have a look at this, and I've produced a worksheet on this, which hopefully has got the same answers as on here. But there may be a few seconds out here and there. We'll just have to see how it goes. So generally, when we set up at ITMM, obviously the total station has no idea where north is. You have to tell it. It can't work it out for itself. So you have to tell it where north is, and you have to orientate it. Okay, you have to orientate it to north if that's what you're doing, or to some other assumed value if that's depending on what you're doing. But typically we orientate it north. So let's say, for instance, we know that the bearing from ITMM to Iron Spike 4 is 163.15.20. So ideally it would be most helpful if we orientated our instrument so that it was reading 163.15.20. But as we know, a second is a very small measurement of arc, and particularly over on an instrument. So on a small instrument. So we try and set as close as we can 163.15.20. Now in this case here, we set the right face at 163.15.16 when we read it, and then we flick it over onto left face, flick it over onto right face, 343.15.38. Now we need if we take the mean of those two, 16 plus 38 is 54, half of that's 27, so that would be halfway between 16 and 38, 27 seconds. So we've got 163.15.27, but hey, we didn't want that. We wanted 163.15.20. So we've got to take 7 seconds off, okay, to get down to 20. Now that 7 seconds, that's got to come off all the other subsequent bearings as well, because the angles between the points will be maintained. All we're doing is just twisting it around slightly to orientate it. So the 7 seconds is the orientation correction, and that comes off the mean of all the other bearings. Remember, it's the mean. So 32.54, 33.16. 32.54, 6 seconds up to 33 seconds, and then 16 seconds. That's 16 and 6 is 22. Half of 22 is 11, so we can take 11 off there. 33.05 minus 07, so that would take us back into 32. So 225, 32.58. This one here, 56.47, 13 seconds up to 57. Then 3 is 16. Half of 16 is 8. 47 plus 8 is 55. So we get 56.55. 285, 56.55 minus 07. 285, 56.48. Okay, 00.27 and 301, 00.27. 120, 59, 54. Oh, it's going through a degree as well. So 6 up to the 20 is 33. Half the 33 is roughly 16. Okay, take 16 off, 301, or maybe 17, 301, 00, 10, and then take the 7 off, 301, 00, 03. So yeah, pretty tricky one there. 37 and 3, both on the same there. That's 40, half of that's 20, minus 07, 2 degrees, 16, 13. So these are the little sums that you do at each setup. Remember that you just set up and orientate once, and then you read off all the other bearings or directions based on that orientation. So this one here, the back bearing, is called the back sight or the back bearing, is important. When you then go to iron spike 4 and look back at you're going to have to reverse that bearing. So it's wanted to reverse that. It's less than 180, so you add it. So it'll be 343, 15, 20. You can look up here, it'll give you a bit of a clue. 343, 15, 20. Okay, so moving on. Doing these means and things as I've just done, meaning the left and right face, can be a little bit tricky if you're not sure about how it all goes. It's just the same as time. It's just like if it's 11:45 and 5 past 12, and you want to go halfway between 11:45 and 5 past 12. Well, it's 15 minutes to midday, and then 5 minutes past is 20 minutes. So if you want to go halfway between there, you go 11:45 plus half of 20 is 10, 11:55. Okay, so it's the same with these. Now this one here, there's actually two situations. Both values are on the same minute. So you've got some degrees 14:28 and some degrees 14:56. So they're both going to be on the same minute. You want to go halfway. What you do is just add up the seconds. 28 plus 56 is 84. Half of 84 is 42. That's your mean. So your mean's going to be some degrees, 14 minutes, 42. So that's for the situation where both values are on the same minute. But if only it was that simple. In some cases, they are not on the same minute. So here you've got some degrees, 38 minutes, 23 seconds, which is just as before 39. And then you've got some degrees, 39:47, which is after 39. Okay, so we want to take the mean or find out where halfway is. So we've got 23 plus 37 will take us up to 39. So 23 plus 37 will take us up to 39. And then we've got 47 plus after that. So that will give us 37 plus 47 is 84. Half of 84 is 42. And then we must add the 42 to the 23, where we started here, which will give us 65, which is 5 minutes past the 39, 5 seconds past the 39. So it's some degrees, 39:05. Okay, so that's how it works. So we've got to be very careful where we're before. The big mistake is to mean these two values here, which they're on different minutes, so that will give you a irrelevant and totally wrong answer. So there's a couple of little concepts there that need to be grasped pretty quickly. Okay, is your diary up to date? Salvador Dali there, surreal artist from the early 20s. Is your diary up to date? So yeah, getting your diary up to date, important that you update your diary regularly, okay, and in real time, because if you're doing it all in a hiss and a roar at the end of the semester, not only is it going to be wrong, but it's going to be harder. Okay, and worksheets. Have you handed your worksheets in? Your worksheets and the efforts that you put into those are starting to pay dividends for those who have done their worksheets, as I notice that they have a pretty good grasp of what's going on. They seem to be up to date with their Travis assignments and everything seems to be going smoothly. I have observed 1 or 2 people who don't seem to have handed any worksheets in. And my observations, my anecdotal observations, seem to be that they don't really know some of the things they should and what's going on, and that particularly in the practical exercises. So the worksheets, in my opinion, really are worthwhile keeping up to date with those, and it's quite noticeable that those that have kept up to date seem to be doing quite well in the practical exercises. Assignment 2 is traversing. That's what we're working on. We're on the 2nd week of that now, and people are starting to, well, should have it sort of sorted out as to where their traverse is and what it is they have to do. So I'm asking that everyone focus on getting their traverse closed in the first instance. So you should definitely be having your traverse closed today in the second go out in the field. And then we'll start to look at measuring to the posts and various other pegging ties. Don't forget to do your independent checks by checking a couple of things independently, and to other survey control marks so that you can check everything out. In the 3rd week or the 3rd session, I'm hoping that that's what we'll reserve that for, doing the topographical work and getting all our topographical shots done, and that should see us through to the collection of all the data for the traverse assignment. If you're wondering what's happening after in the 4th week, that's when we'll get the GPS out, and we'll start to have a look at setting up a GPS and how we can do everything that you've done in the last 10 sessions and very efficiently in a much shorter space of time. But that's how we roll. And finally, what's new in Moodle? So this is the what is new in Moodle. So we're going to pop over now to the Moodle site, and we're going to have a look and see what's new in Moodle. So it's land surveying there, and here it is here. And well, let's just go to the home tab first and see if there's anything of note there. Nothing particular to note at this point in time. Assessment wise, just would point out that the levelling test results, preliminary results, have now been posted, and that they're posted down here. And I have done a video of a review of the test. Now you might think that the test is history, but that's not so. The questions and what have you in the test and the fallout from the test will in all likelihood be in the exam at the end of the year. So it's important that any learning opportunities that cropped up during the levelling test be sorted out at this point in time, moving forward with constant review. We do have a traversing test will be coming up soon in a few weeks, and so here's some previous traversing tests for you to have a look at with their model answers and start to become familiar with the sort of things that you could expect in the traversing test. So that's in the assessment front, obviously. Traversing assignment due 22nd of May, so that's the next big thing. And there is a national exam which will be occurring at the end of the semester. Alrighty, so I have added a few things to various other ones in the space since I talked to you last. Not quite sure exactly where I've put some of these things, but I have made a few videos in response to various things. So yes, I did this video here on worksheet 48, how to calculate the Bowditch adjustment. I had a question on that and was asked about that, and so I put that video there. I have had a couple of videos here on bearings are measured clockwise from north is a new one that I've produced, and degrees, minutes and seconds on the Casio FX82 is a useful one, and also land surveyor meaning the faces, which I've actually done a similar one in this introduction here as well. Okay, so let's go to linear measurement, and we've got here a lot of information on linear measurement, some video, a couple of videos there to watch, and a bit of a quiz and some comprehensive notes here on linear measurement. So these are the notes that are available. I would recommend that you certainly read through those and have a good look at them. They explain a lot about linear measurement and some of the concepts and things that it works. So if you sort of need a little bit of more background, I would recommend that, well, I recommend that you read this anyway, but certainly provides some better background for you. There's the quiz there, the session plan and what have you there. Reducing short lines. This is a little activity on reducing short lines, and there's a little video in there to watch. A very nice little website there that's worth a visit, showing you a little bit about EDM reduction, and then the worksheet with the answers found there. So that's all well and good. Okay, so let's go back to there. Reducing short lines, reducing long lines is in a similar vein, but just talk a little bit of a video on sea level correction, which sort of comes into play with your longer lines, like so. All right, and then we have some video here on bearings, faces, and orientation corrections, and a worksheet, whole circle bearing calculations. There's not too much there by the way of videos with those, so someone may ask a question of that. It may prompt me to do a video and what have you. Faces and the orientation correction, which I've actually looked at in this introductory one. Whole circle bearings, these tend to come up in the end of year exams. This is a little one here. I've introduced how to convert from polar to rectangular. So I have shown you up to now how to just use the basic sine and cosine, how the cosine of the bearing times the distance will give you the northing, how the sine of the bearing times the distance will give you the easting, and how you can work out going from rectangular to polar by tan to the -1 of distance difference east over difference north, or whatever's appropriate. But there is another way of doing this, and this is using polar to rectangular conversions. It is possible to do this on the Casio FX82, and so I've produced a little video here showing you how to do that. It is important that you understand the base. Have a basic go-to one that you can go to, but this one here is worth perhaps having a look at once you've become quite familiar with some of the other methodologies, and if things don't go quite so well, you can drop back to that. I've got a video here on the bearing rounding, my bearing rounding guide here, and the actual guide itself, a copy here of the guide. So this is gives us some guidance as to what accuracy we can round our bearings to without them having too much effect. So obviously over a very short line, over 10 meters, 1 second of arc is only 3 millimeters, or 1 minute of arc is only 3 millimeters. 30 seconds is 1, and 1 second of arc is negligible over a 10 meter difference. So obviously showing a bearing to the nearest second is a bit of a nonsense. So that's a bit of a video explaining that, and how it all works for rounding your bearings, so that you have, you know, some common sense sort of stuff in what you do. People don't look at you and think, oh, okay. Right, and then that follows through with the usual some exam questions and some practical tasks, of course, signed off with your, don't forget to put in there your health and safety documentation specifically relevant to the particular day, and your field notes and whatever that you collected. So that brings us to the end of the thing. And what does success looks like? Well, it looks like a document that you've put together, one PDF document that you have sent off to your tutor. And here's an example of what success could look like. So you've got here the thing there with your, definitely with your checklist all completed properly there, your quiz done and filled out and marked. Have a look, make sure you've got the right answers, because if you learn from the wrong answers, well, you won't learn because you've got the wrong answers. These are the short lines and long line reduction sheets, which you should be able to become familiar with and be able to reproduce these results here at, you know, there, the faces and orientation correction there, the whole circle bearings exercises, which are fairly typical questions for the end of year examination. Some Trevor's closures, in this particular one, it is done off a Trevor's sheet, and again, this is where you might want to bring into play the polar to rectangular coordinate feature that I indicate in the video within the body of the stuff. The exam questions are this one here, mostly about the accuracy of linear measurement and that type of thing. And then your practical tasks, of course, with the supporting documentation, your field notes, and I've just put a generic health and safety, but you should have the health and safety one that is relevant to the work that you've been doing. And this will all be put together in one PDF document and emailed to your tutor. And that sort of brings us to a conclusion there. So we end up with another session 9. A little bit of work to do there, mostly around the traversing assignment, but all the work that you do, all the worksheets and that are particularly relevant to tasks that you have to do as part of the assignment. So it's just as well to practice them and get them done and get them sorted, so that when you come to do your assignment, it's a smooth workflow through it, and that you smoothly work through your assignment and come up with a very nice professional looking document. So that's it from me. Cheers. See you.